Hi everyone, here are your notes for section 5.1, which gets us into mid-segments inside of triangles. So what is the mid-segment? The mid-segment of a triangle is a segment that connects the point of two sides of a triangle. So if we were in class, we'd be doing this with a ruler and pencil and doing all of whatever we would need to do to get exact midpoints. For those of you guys who are at home, I'm not expecting you to do that, so we'll just pretend that we're doing a really good job of finding the midpoints. So, to create a mid-segment, you have to find the midpoint of one side of your triangle. And remember, a midpoint means that the top and the bottom would be equal in length, right? And then you would have to find the midpoint of another side of the triangle. So I'm going to do the right side. And that means that both of those sides would have to be congruent. So I'm going to put double tick marks there. And a mid-segment then is the line that connects those two midpoints. Now I did not do a good job because that technically should look parallel to it. So let me make mine a little bit better here. It was maybe there, shooting straight across. Nope, that still doesn't look very parallel. Does that look parallel? There we go. That might look a little bit better. Okay, so there is our mid-segment. And then what did we learn about that? Well, we learned that the mid-segment is parallel to the third side, so the side that you did not find a midpoint on, and it is half the length. So if this is x, then the mid-segment would be half that. Because it is parallel, I know that I have congruent angles, right? Corresponding angles are congruent, so those angles would be congruent, and these angles would be congruent with each other. So that's all the fun stuff that we have going on inside that triangle due to just having a mid-segment. So here's our theorem. The mid-segment theorem tells us that it's parallel to the third side and is half as long as that side. So go ahead and pause this so you can get that written down. I'm going to continue going on. So let's go ahead and find the value of x. So x is on the mid-segment. Clearly x is smaller than the third side, which is 18. How much smaller? It's half. So x is going to be equal to my third side cut in half, which is 9. Now we're going to throw some algebra involved here. So now my x again is on my mid-segment. So my mid-segment is equal to half the third side. The third side is 70. What is half the third side? 35. Solving for x gets us x is equal to 7. There's another one. We have 5 is now the mid-segment, right? So again, we have my mid-segment is equal to half the third side. But wouldn't it be easier to do it in reverse? If my mid-segment is 5, what would the third side have to be? Wouldn't it be double 5? Which would be 10, which I get that by multiplying this by 2 on both sides. So now we have 10 is equal to x minus 1, which tells me x has to be equal to 11. So if that third side needs to be 10, your x would need to be 11 to be able to get 11 minus 1 to equal to 10. Okay, and then we have this diagram yet. So it tells us that points E, D, and H are midpoints of triangle TUV. Now I'm going to do some labeling. So we know that we have midpoint, 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 midpoint. So that gets you all those parts equal to each other. UV, we're told, is 80. So that makes each of these halves 40. TV is 100, which makes each of these halves 50. And HD is 80. HD is the mid-segment, right, which makes this third side double that, so 160, which makes each of these parts 80. All right, so we're asked to find HE. So HE is right here. It's a mid-segment. It's parallel to that third side, so it's going to be half of that, which would be half of 80, so 40. Next one, ED. So ED, now I lost everything. ED is right here, right, which is parallel to TV, which you guys should hopefully have that. That's labeled as 100, right? Half of that would make us have 50. So ED is equal to 50. TU, I think we already labeled that, right? HD we were told is 80, so TU would be double that, so 160. TE is right here. So if this whole thing is 160, then each of these would be 80. And that concludes those parts of the notes. So some other things that you will have to do for the homework, you're going to have to be able to identify parallel lines. So I'm going to make, let's add on to our notes here. Let's do an E. So which side would be parallel with side TV? Which line? So here's TV. What would be parallel to it? ED would be parallel to it. Let's add an F. What would be parallel to HE? So HE would be parallel to what? Well, HE is here, so that would be parallel to the third side, which is VU. Is that a VU? Yeah, VU. Okay, so make sure you can identify the parallel parts. What would be parallel to EFG? Let's go with EU. What would be parallel to EU? So EU's here, so HD would be parallel to it. Okay, so make sure you can pick out the parallel parts too. So a midsegment is parallel to the third side. It's also half the length. Okay, so you might want to put a star somewhere in your notes and write that your midsegment is, I should have given myself some more room here. My star over here. So your midsegment is equal to your third side cut in half, or you can think about it as 2 times your midsegment would be equal to your third side, right? Because you can double your midsegment to get to that third side. Both would work. All right, that concludes your notes.